Hello and welcome to Mirror Modal Dev. I'm Ash, and I'm really excited to share that recently an app I've been building was featured by OpenAI, and I want to walk you through how it was featured and show you the feature that caused them to feature this application. And then I actually want to talk you through a little bit of how it works under the hood so you can try it as well. We're going to be talking about the OpenAI Responses API. And within that context, we'll talk about things like streaming responses, which might be table stakes to some of you, but there's also some other fun things in there, like being able to cache context on the OpenAI side, and even things like built-in tools and creating your own custom tools. So we'll talk a little bit about all of that. But first, let's just have a look at how the app was featured. So we have here over on this side, the OpenAI Developers blog, and there's a section in here on a recent post that they put out about the Responses API and its first year birthday. So if you know a little bit of the history, the Responses API has gone through a few iterations, including I think it was called the Chat Completions API, and then the Completions API, and now it's the Responses API. I've had a bit of history building on all of those iterations of the API, and I'm really excited about the Responses API because it's just kind of unlocked some things that went from making it kind of a fun trick that I could demo to people to actually being able to build a production feature. So we'll talk a little bit about it, but you can see here in the blog post, I'll have a link in the show notes as well where you can check that out and have a look. But let's actually look at the feature actually running in production. So Collxn is an app I build for vinyl record collectors, and every day what it does is it pulls a record from your collection and then gives you some interesting information about it, or just reminds you that you have a record. So if you're into vinyl records, you might possibly have tens or hundreds or even thousands of records. It gets pretty easy to kind of lose touch with some of those records, and Collxn is really just about helping you get back in there and try some records that you might have forgotten about and really help you to enjoy these records that you already own. So this is my page, and you can see here that over the last few days, it's pulled some different records from folks like Haruomi Hosono or The Strokes, and so on. So just as an example, we'll pick this one here. This is a Gorillaz album called D-Sides that came out after the album called Demon Days. So it's a lot of variations on tracks from that era of Gorillaz, if you happen to know it. So this is what the daily drop looks like inside of Collxn, and you can see we've featured the album up here at the top, give you some of the streaming links, and then down here there's other records from Gorillaz in my collection, as well as similar vibes that I might want to check out. So it selected some things by Shabazz Palaces, Sweet Trip, and Stereolab, all of which I'd get very excited about. And then down here, it pulls up some recent news, which, by the way, is a feature that's also using OpenAI. It's using the Agents SDK to go out and pull recent news about the featured artist. We're not going to really talk about that today, but that's another feature I have running using OpenAI APIs. But what we are here to talk about is if we scroll back up to the top, we can look at this chat box here. And this is a feature called Ask This Drop. This is running on the OpenAI Responses API. So if I pull that up, I can just select one of the questions that I have listed there, and it'll tell me a little bit about the album. So it says that D-Sides is Gorillaz in odds and ends mode, and it has like things like trip hop, left field electronics, alt rock, and pop, which is really cool. It even tells me a little bit about my own copy of it, because if you collect records, you'll know that there are multiple pressings of any given album most likely out there. So my copy is the vinyl LP Record Store Day, remastered, yada yada. So I could ask other questions about it. For example, like how much is this going for on Discogs? And I don't intend to sell this record. I generally don't sell my records anyways, but it's there are a lot of folks who like to look at this kind of stuff, and folks that use Collxn will indeed do a lot of buying and selling. So if you noticed, while the bot was thinking there, what it did is it went out and used the Discogs API to get that latest pricing information, and even gave me a link to the Discogs marketplace. Well, that's using something called a custom tool that I built to work in concert with the OpenAI Responses API. So we're eventually going to talk about that, but before we do, let's just kind of get into the basics of how this stuff works. So we'll actually cut over here and have a look at what it takes to just kind of get up and running with the Responses API, and from there we'll go a little bit deeper. Hope you're excited to follow along. So before we get into the code at all, let's look at the concepts that we're going to be covering here. So we'll start pretty basic, and over here on this side we're going to have an app server. That's the server that we control, and that's the one that will be making requests to OpenAI. And then on this side, of course, we're going to have the OpenAI server here. And so all we have to do now is just make these sort of basic requests like we might do for any web app, right? So these are just going to be basic HTTP requests. Of course, we might be we might be using an SDK for this, and indeed today we will be. So it's not like we'll just be seeing raw HTTP requests being made, although we could certainly do that. So over here, what we're going to do is when we make the request to OpenAI, this is going to have a lot of information in it, but just to keep things super simple, this is where we send the prompt to the LLM, right? Now, of course, there's going to be more information in there, like, for example, what language model do we want to talk to and all of that stuff. Well, we'll see that in a minute, but for now, let's just keep it simple. And then on the other side, of course, we're going to get the response back from the LLM. Of course, it's never quite as simple as this kind of just, send a prompt and get a response. But that's a good thing because we get a lot of control over how we work with it. And in fact, the first thing we're going to look at is 2 different ways to handle that response. So let's jump over into the code. Here we are in VS Code, and I've set up a small project that we're going to run through to show the differences of what we can do with the Responses API as we go. So just to familiarize you with what you see on the screen here, on the left-hand side, of course, this is our file explorer, and on the right-hand side, we have Collxn opened up. And I have a thread here where I just asked it to keep this thread open in case we want to modify code in real time with the bot. And that way we can just keep it all here instead of jumping back and forth between here and, say, the Collxn app or something else. So inside of this repo, we have a number of files, but the main ones we're going to be focused on here are these different TypeScript files that all show a different variation of doing something with the Responses API. So the first thing we're going to do is just start with number 1. So here we go. And it's super simple. We open this up, and you can see here that we import our .env file. Of course, that's reading in our OpenAI API key. So if you were to go along with this repo on GitHub, you'll set that up as part of your setup steps. So we don't have to cover it here. But we're importing .env, and then we're importing the OpenAI SDK. And then we just instantiate that OpenAI SDK with our OpenAI API key, which you see here. Again, this is made available because we have pulled in .env. And then from that, we'll just say that if we have in .env a preferred OpenAI model, we'll use that. But if there's nothing there, then we'll default to GPT 5.4 Mini. Now, I happen to have one set up here, but at the same time, if you don't want to do that for some reason, this code will just fall back to that model. And then after that, we just have a very, very basic SDK interaction here where we're going to get a response by awaiting client.responses.create. We pass in the model, and which again is going to default to GPT 5.4 Mini. And then we'll just have a single input, which is in one sentence, explain what the Responses API is for. So I've made a few convenience NPM scripts here that we can have a look at. But this first one we're going to use is first call. You could also just do node and then the file name as well if you prefer that method. So we'll make the call. It's probably going to take a second, but not too long, right? And you can see here that it came back with an answer. The responses API is used to create AI model interactions that can generate text and take actions like using tools, making it easier to build assistants and agent-like applications. So that's it. That's your first API call. It's super simple, and to be honest, it always has been. This API has seen multiple iterations on it, but the basic kind of interaction model at its core has always been something along these lines. And so from here, you can imagine, right? We could, for example, extend this script to just make it be an explainer, right? Where we let, say, for example, the user pass in some kind of input on the command line and then pass that in as input here. Well, let's go ahead and do that. So we will go ahead and just talk to the bot here and just say that we want to optionally be able to pass in a string. I just want to be able to show you that this stuff is like already capable of doing that kind of thing right out of the box, and you can get a baseline idea of what is possible without a lot of code. For the first call file, let's optionally let the user pass in a string as an argument that would complete the input sentence. So instead of the input sentence being in one sentence, explain what the responses API is for, let's have that responses API be optionally changeable by the user based on the input string from the command line. Okay, so you can see here that we have basically two lines that were changed. The first one is that we have a new line for the subject, and it just pulls in our command line arguments from process.argv, and it will default to the string, the responses API. And then inside of our call to OpenAI, you can see here that on the input side, we're just using a template string to say we just pass in subject. So at default, it will be the responses API like it was earlier, but if we did pass a command line argument, then it'll pass that in too. So let's just do npm run first call, and then we'll do double dash so we can pass in an argument. And we'll just say, why don't we talk about this? Because this is what we will be talking about next. So we're going to pass in the word streaming responses, and let's see what it comes back with. So streaming responses let a system send data to the user incrementally as it's generated so they can start seeing results sooner instead of waiting for the full response. That's really cool, right? So now we can pass things in. Of course, if you're building this into an application, please be careful. Like, we could pass in any sort of insanity as an argument, and all sorts of crazy things can happen if you're not careful in production code. But we're not building production code right now, so we're going to keep it pretty simple here and just leave it at that. So you can see here, though, with 16 lines of code roughly, you've got something where you're already talking to an LLM over the API. So now let's actually get into that streaming responses thing, because I want you to notice this one more time. I think let's do this just to make it quite clear what's going on. So I'm going to hit save, and instead of one sentence, we're going to ask for 5 sentences, and we're going to do the same thing for streaming responses one more time. So we're going to call that. Notice how we waited, and then boom, all of the response came back at once. So that's not like what you would see in ChatGPT. It's not like what you saw in the Collxn Ask This Drop feature. We wait, and then boom, it all comes at once. This was a small response, so it didn't feel like it took too long, but it's still kind of jarring when it all just kind of lands on us at once. So you can imagine where this is going already. Next up, we'll talk about streaming. So the good news here is that streaming is also not particularly a lot of code to get it running at its most basic level. So again, we're importing .env and the OpenAI SDK. We instantiate that SDK with our API key. We select the model based on our environment variable, or we default to GPT 5.4 mini. Nothing here has changed so far. What does change is now we're just to be clear, we're naming our variable here stream, whereas earlier, if I flip back over, let's put this side by side to compare. If I flip back over to our first call here on the right-hand side, you'll see that we just called it response. We're calling this one stream. That's arbitrary. We could call this anything we want because this is just the variable that we're setting, but the API call in the beginning looks exactly the same. We're doing await client.responses.create. We pass in the model, we pass in the input, and then the only difference in the call is that we pass in stream is true. So we're adding that to the end. Here you can see that in our first call, we didn't have that. If we did want streaming responses, we would have to put it here. Do stream is true. In this case, it's defaulting to false because we haven't built how to handle that streaming response. So that's what we're going to do here, down here below, where we're just handling it in a simple for loop. And so you can see we have for, and then we're awaiting, and it's a const event of stream. So for in the stream, whenever something happens, we're going to run this if statement that says, so if the event.type is a delta, so a change in the output, then we're going to write that to standard out in our terminal. And so let's go ahead and run that and see what it does. So we'll do npm run, and then we have, again, like a little npm script that just says streaming. Again, you can use the node command to run the file directly as well. We already have a default input, so we don't need to pass in any arguments. Let's go ahead and let that run. And you can see there, it looked like it was typing, right? Now it went by very fast, so it might be a little tough to see. Let's do this instead. We'll just do write 10 bullet points, and let's see if it does. See how it's going there? Slowly, bit by bit, and it passed in all of that. Now, if we were to kind of go back to this other way of doing it, we would have had to wait for all of that to show up at once. So without belaboring the point any further, streaming is just a nice way to get responses back in something that feels like real time. So it doesn't change a lot. In either way, we're making a request over to OpenAI by passing in the model we want and our API key and then the input as a prompt. But we can also, if we want streaming responses back, then we can pass in that one little thing that says, stream is true. And then when that happens, instead of OpenAI waiting until everything is done to send it all back at once, it'll send back output as it's generated. Now, we saw earlier in the code that there's nothing magical about getting those chunked responses back. If our application doesn't handle it, we could still make that feel like it's a blocked response. If we only print out when the request is complete, then we could still mimic what we had earlier when we weren't streaming responses at all. But because we had that for loop and we were handling the output as it came, we could mimic that feeling of something typing back to us in real time. So this is the most basic parts of what you might do with the Responses API from OpenAI. You make a request to a large language model and you get back a response either all at once or chunked as the tokens are generated. So let's now put this aside for a second, and we'll go back and look at something that might be a little more interesting and kind of talk about a little bit more of power features, if you will. So far in our examples, what we've seen is basically asking one question and getting one response. So let's just kind of mimic that here in freeform for just a second. So let's say, for example, we'll do this. What is the Responses API? So we passed that in across over here to OpenAI, and we handed that to OpenAI, and then over here it gave us an answer, and let's just say that the answer was it's an API from OpenAI. We'll keep it simple. So then it passed back a response, and so now over here on our side, the user can see that response. And maybe it gave it to us in a blocking way, or maybe it gave it to us via streaming, but either way, this string is now sitting over here. Well, what if we wanted to ask a follow-up question? Let's say, for example, can it handle JavaScript. Typing skills on display today. All right, so, oh, can it handle JavaScript? And then I pass that over here. But what's going to happen? Well, the thing is that we're not storing up any context as we do this. So what's it? What is it? There's no way for OpenAI to understand that. And so I'm sure it'll take a pass at giving you some sort of realistic answer, but it might be like, I'm not sure what you mean by that. But the thing is, because there's no connection, right? If you look over here, just in this kind of crude sort of graph or chart that I've made, you can see that all that's over here is questions, and really even this question no longer exists, right? Because we started up a new conversation, and so it's like starting a new conversation with ChatGPT by saying, oh, can it handle JavaScript? Well, what's ChatGPT going to do with that in the first place? So this is the same thing that's happening here at the API level. So generally what you would need to do instead is first you pass this over, right? But you're probably also going to keep a copy over on your side, because then when the API gives you a response back, again, just keep in mind, none of this is being stored over here. So you would have to handle the state management all on your side. So you pass in, so let's say the user now wants to ask this question. Well, what are you going to do on your application side? Well, you're going to have to compile this entire conversation and then pass it over to OpenAI, to which OpenAI is then going to pass you back a response, right? So it's received this entire conversation and it's going to pass back a response that says, yep. And then it'll hand that back. Again, there's no context sitting over here. It's up to your application to maintain that context. If the user then wants to ask a follow-up question, then again, you're going to need to make a whole new or make a whole new question here, or statement or whatever, and maybe it's something like this, and then you pass all of this back over to OpenAI, and then OpenAI is going to generate a response. It's going to generate a response for that, and then again, and it's just going to pass you the response, and then it's your job to add that response onto the end of this conversation in case the user wants to continue that conversation with context. So this is doable, and it's not the biggest thing to push uphill if you needed to for one user or a few users. But when you think about maintaining that context for everybody and all of the added data that you're passing in over the network every time just to maintain context, that starts to add up. And of course, the Responses API offers a solution to this, and we're going to talk about that. That solution is stateful conversations. All right, here we are back in VS Code. I've gone ahead and reverted our first call script back to what it was originally. So you can see here, there's no way to pass in a command line argument, because that's not really what we're interested in at this point. We're not building on the script in any way. But what I wanted to do is just call your attention to the fact that when we log the response, right? Let's just call that one more time. You notice that we just have that response right here in standard out. But of course, there's a lot more coming back in the response than just the output text. So let's just hit save on that and run this one more time. And you're going to see this big gnarly JSON object that we don't need to focus on in any level of detail. So don't bother zooming in. You don't have to. The only thing I wanted to point your attention to is that in there's an ID for this response. And that's what's going to unlock stateful conversations for us. So we'll go over into our script here, and we'll have a look at this third script. It's called stateful conversation. And let's just kind of compare to the first script just to show that at the beginning, there's nothing new going on here. We pull in our environment variables with .env, and we pull in the OpenAI SDK. We instantiate that SDK with our API key, and then we set a model either based on an environment variable or default to GPT 5.4. Now we get into the SDK interaction where we're going to call, in this case, we'll call our variable first response. And you'll see that the actual method signature is going to be the same up front. So we're calling client.responses.create. And for the most part, we're passing in the same stuff that we did earlier. So we're passing in the model, and then we're passing in some kind of input. In this case, it's hard-coded to say, tell me a short joke about JavaScript. But of course, you're going to notice here that there's a new line. And instead of it being stream true, we're saying store true. That's unlocking stateful conversation. So what's going to happen is if we flip back over to freeform for just a moment, we'll be able to now expect that OpenAI is indeed going to store some sort of reference back to that conversation so that next time I don't have to, as the developer, recompose this whole conversation just to ask a follow-up question. I don't have to explain what it is. I can just pass this question over and it will be able to send a response back like this. So it's going to store context for this conversation, and our way to reference the conversation, the ongoing conversation, is with this ID string. So that's what we're going to work with here. So you can see we got the first response, and it's going to console log back some information. So we'll have a look at that in a second. And we'll make a second call here. And inside of that, we're going to reference that first response.id. So we're going to have a look at this in depth right now. As a matter of fact, before we even get into the second response, let's go ahead and comment this out. And then we're going to run this script down here. So we'll do, instead of npm run first call, I think it's streaming. Yep. So we'll do npm run streaming. And this should just give us back, we'll expect that we've made this call to OpenAI. It's going to give us back the first response and the first response, this hard-coded string first response, and then it'll give us back the dynamic answer. One other thing I want to show you is that we're also we should expect that we have this first response dot ID that we can look at, because that's just here in the response. So I want to go ahead and console log that too, just to show you what we'll be working with. So we'll do first response dot ID, and you can expect that that's just going to be this long string, but that's the crux of the whole thing here. Sorry, we don't want to use the streaming script. We want to use the stateful script. So we'll run that. And nothing particularly interesting should be happening here. We see the string come back, and then we see, this is just the hard-coded string, and then we see whatever the joke is. So TypeScript developers never argue, they just type things out. And then there's the ID. So it's this RESP prepended on the front of it, and then a long ID. So great, that's what we expected. And remember, we have store is true. So what that means is we should be able to reference this conversation going forward. And that's what this block down here is doing. So let me uncomment this out, and you'll see we have now a second response. It's the same method call. So it's await client.responses.create. We pass in the model just like we did before. We pass in the input, so we're as the role of user, and then we'll ask for a follow-up on that joke. And again, we continue to set store is true. The one thing that's different here is that we refer to the previous response ID by using first response.id. It's that same ID we just saw in the console log. And then we'll go ahead and show second response and then the output text. So this is almost like a user following up. We're just kind of scripting our own side of the conversation just for the simplicity of doing this in a video. So we'll do npm run stateful. Oops, I didn't save the file. So let's go ahead and do that again. And we'll do npm run stateful. And you can see it came back in two different responses, right? It kind of had to wait there for a second. So the first response is, why did the TypeScript developer bring a ladder? Because types were too high up to infer. All right, so there's a response ID. And then second response is, it's going to explain this terrible joke. And it's a wordplay joke in TypeScript. So you can see here that it's actually referring, it knows that it was talking about TypeScript. It knows that it was referring to something being too high up. And so without us, you'll note that in the second response call, we didn't have to do anything about passing this lengthy input. So earlier when we were looking at Apple Freeform and we saw kind of all of those requests and responses bouncing back and forth, there was a lot of work on the developer side to kind of eventually kind of have to build up this whole script down here where it's like, okay, first response, second response, and so on. You would have had to do that previously. But with stateful conversation, you don't have to do that. You've set store to true. Now you can refer to these interactions that you've had previously. And so we can even go a step further here. And let's just try to do something in real time here. We'll do third response, await client.responses.create. We'll pass in the model. We'll pass in the previous response ID. This time we're referring to the second response. And then we'll do an input. And then it'll say, now make it a, how about we do this instead? Now tell me if you really thought that joke was funny, and we should get back third response and third response output text. Let's see here. I wonder if there's any way that we can get it to refer to the second response. I'm just trying to think through if ideally what we would like is just to prove the point that it's slowly building on the full thread, that it would acknowledge the fact that any of those explanations add up to being funny. So maybe that's what we should say. Now tell me which of those explanations is the best reason it's funny. Okay, maybe this will work. But again, the idea is what we're trying to show here is you can see first response, second response here should be building third response. So let's see. Unfortunately, we'll have to go through bad jokes a little bit more, but let's just look here. So first response, why did TypeScript developer go broke? Because they kept spending all their types on declarations. Okay, I don't know. But anyway, second response, it works because it plays on TypeScript specific jargon. So it's going to refer back to types. Spending type sounds absurd. Declaration, same thing. And third response, the best reason is the long wordplay on TypeScript jargon. So it's kind of referring back to something in here about saying wordplay, even if it didn't call it out specifically, because it's just talking about overall jargon, right? So anyways, not the funniest thing we've ever heard in our lives, but the point is that not so much about the joke itself, but what we're trying to prove is that we're able to start stacking up on context. And so on the developer side, this starts to simplify things quite a bit, as we talked about in Freeform just a moment ago. But if we were to come back to that diagram for just a moment, you can see here that instead of necessarily storing all of that context on our side, we are just able to pass in additional prompts with IDs. So what that does imply is that the storage challenge for us, and again, you might say, I still want to store all of this history. Great. If you do, that might be wise if you want users to be able to refer back to their full context in the future. But at bare minimum, you know that you're going to need to store these conversation IDs so that if the user decides they want to stack up on kind of continuing, you won't have to construct that full conversation and then pass that full conversation over the network and have OpenAI reprocess that from the start. So there's still going to be some decisions for you to make as the developer, but at its core, this is much simpler. It's much more lightweight on the network than these growing giant scripts that you would have to pass back full transcripts of over time. So there's something really powerful about stateful conversations, and I'm using that in Collxn today, and I've been very happy with it. So as a very quick review over all the stuff that we've been looking at so far, we made our first call, and we did it by simply passing in a hard-coded input, and then we even looked at how to change that input with using command line arguments, just basic JavaScript stuff. but we pass in some kind of prompt along with the model in our API key, and then we get back a response from the large language model side. And then we looked at how to take that and make it not blocking, but streaming. And that was pretty simple. We just had to pass in this object property stream is true. And then more importantly, we need to make sure that our application server is actually set up to benefit from that by receiving these events and then doing something with the events over time. So we can handle that at its most basic form with the simple for loop, which we looked at here. And then finally, we looked at also stateful conversations, which dramatically simplify what we need to handle as the developer in terms of keeping track and then constructing and passing all of this information if a user is trying to have a larger conversation with a model. So all of that comes together to start making something a bit more compelling than just simply passing in prompts and then waiting for those prompts to resolve and then getting back a giant chunk of text. So I hope this was useful for you. Next time around, I'd like us to get into tool calling, and we can look at a couple of different types of tool calling. There are built-in tools inside of the OpenAI API that we can benefit from. One that I use inside of Collxn is web search, which is awesome. I'm using it both in the context of the Responses API as well as the OpenAI Agents SDK, and it's really cool. But what's even more fun is that we can build our own custom tools as well and make OpenAI aware of those without handing over the keys to everything to OpenAI. So we can look at that as well. In our brief example from Collxn earlier, you'll remember that we looked at a Gorillaz album in my record collection, and then we asked about how much that Gorillaz album is going for on a service called Discogs. And the bot was actually able to go and look that up, but that wasn't purely OpenAI going and trying to scrape that data. What it was is it was OpenAI being aware that my application has a custom tool that it can use an API from Discogs to go look that information up. And so that's a custom tool, and sky's the limit on what you could do with that. But next time around, I think we'll kind of block that concept of tools together and look at both built-in tools and custom tools that we can build. So thanks for following along. I hope you got some use out of this. Let me know in the comments like what kind of stuff you're building with it. And if you have any questions, I have previously made videos in response to folks asking questions in the comments, and I'd love to do that. So if you have any specific questions about this stuff or things that are related, let me know, and I'd be happy to consider kind of looking into that and talking about it. So thanks for following along with Mere Mortal Dev. See you next time around.